we've got a relatively short lesson here for section 3.8, and it's on radical functions and inverses. So first of all, radical functions. Functions involving roots of variables are often called radical functions. So what they look like is something that will have this sort of radical sign in it. It might have a number up here as the index, or it might not. It might be a 2, or it might be something other than 2. But those functions that have those in it with an x inside of here, or any variable inside of there, that's what makes it a radical function. Okay? So we're going to talk about some of those as we go through these inverses. But the other thing we want to remember is inverse functions. And I think we've actually talked about these before with other types of functions. But inverse functions are functions that undo each other. Okay? So functions are kind of like directions. And I think I probably used this example anyway, but we're going to do it again. And that will, you'll remember it. Oh, yeah, we did talk about this. Or you'll be like, no, we never talked about this. Yeah, whatever. So if I ask Concha to give me directions to get from here to Walmart, and she gives me directions, and I follow those directions, I end up at Walmart if she gave me good directions, right? And if I followed them well. The inverse set of directions would send me from Walmart back to here. And so that's what functions and inverses do. They undo each other. Whatever one does, the other one undoes. Does that make sense? So if one function multiplied by 7, the other function would have to divide by 7 to undo what the first function did. Does that make sense? If one function added 3, the other function would have to subtract 3, right? So you end up back where you started. So that's what we're going to be looking at, inverse functions. And our bottom statement here, a function that passes the horizontal line test will have an inverse function. So horizontal, you remember the vertical line test when we were looking at graphs? And if it passed the vertical line test, if a vertical line only touched it once, it was a function. The horizontal line test is very similar. If a horizontal line only touches the graph one time, then it will have an inverse, and it's actually called a one-to-one function. Right? So the reason that horizontal line test is important is because that tells us if there will be an inverse or not, an inverse function or not. So here's how we find them. Are these directions already written down in your paper or not?
Yeah, we have to.
You've got to write them down? Okay, let's get them up here so you can write them down. And there's like 3 or 4 steps. So first step, instead of the f of x, we're going to replace the f of x with a y. So we're going to have y equals whatever the rest of the function is. I think I'm going to get them up here and then I'll let you guys write. Next, we interchange the x's and the y's. So anywhere that it says y, we're going to write x. And anywhere that it says x, we're going to write down a y. Then we do some algebra and we solve and get the y by itself. And after you've done that, that is the inverse. So this is our notation for inverse functions. F, the superscript -1, and then our x. So that's a notation for an inverse function. Is it open?
No, that was.
Oh.
I feel like a breeze coming in.
It must be a bad window. It's letting breezes in. All right. Anybody need more time? All right. Let's do some examples of how we find inverses. So step 1, we're going to write down y equals x minus 2 squared minus 3. Step 1 should be really easy. This might be another 3 steps that you want to put on your note card so you can remember how to find inverses. But I'll let you decide that. So that's step 1. You just copy down the function, but you replace the f of x with a y. Step 2, we're going to interchange the x's and y's. So here we're going to write x equals, and then y minus 2 squared minus 3. So step 1 and step 2 are really easy, as long as you remember what to do. Step 3 is where we actually do the math. Okay, so our goal now is to get this y right here by itself. So we've got to start kind of peeling away the layers to get this y by itself. So what would be the first thing we have to get rid of? Nope, before that even. This 3 is the like farthest out thing. We have to get rid of that first. How do we get rid of that 3? Add 3 to both sides, so that cancels. And now we have on this side x plus 3. Okay. Then what's the next thing we have to get rid of? Now the squared, right? How do we get rid of that squared? We could, but that would make, instead of one y, a whole bunch of y's. So we do not want to distribute here. We take, and I don't know who said it, but you're right. You take the square root of both sides. Just like when we just had x squared equals whatever, 1, I think. And we took the square root of both sides. Same thing here. We're just trying to get rid of this. So we're just going to take the square root of both sides. So this cancels that out. It undoes it. So now we have the square root of x plus 3 equals, and since we took the square root of that, or yeah, we got rid of that, we just have y minus 2 over here. But the one thing we have to remember is we just did this step where we took the square root of both sides. What do we always have to remember to do anytime we take the square root of both sides? Plus or minus. In front of that radical. And then what does it look like? The last thing we should do to get the y by itself? Add 2 on both sides, correct. So this is going to be plus or minus square root of x plus 3, and then it's not inside, it's on the outside, plus 2 equals y. So now that the y is by itself, we're done. So our answer would be f inverse of x, the inverse, is this. Plus or minus square root of x plus 3 plus 2. Now I will mention, I'm not a big fan of this particular notation in this case, and here's why. Because of this plus or minus, this inverse is actually not a function. Okay? Because if you remember what determines if something's a function, that vertical line test, but it also is for every input you get only one output. Okay? So if we put in a value here, let's just say we put in a 1. 1 plus 3 is 4. Square root of 4 is 2. So that means we'd have 2 plus 2, which would be 4, or negative 2 plus 2, which would be 0. We're getting 2 different outputs. Okay? So the only reason I don't like it is because this looks like it's a function, and it's really not a function. So I don't really like that notation there, but that's what the book used. I guess if you put them together as 2 separate functions, you could get a combination of them that is a function. But the reason I point that out is, does anybody remember what shape this is? Because of that? Because it's squared? Yeah, it's a parabola. Yep, several of you are giving me hand motions. Yep, you're right. It's a parabola, so it looks like this, or something like that. Do we see how if we tested with the horizontal line test, this will not have an inverse function, right? Because it'll hit more than once. Okay, so I think there's going to be a problem in the book, and we may have one later on where they say, limit this so that it does have a function. And what they mean is, just decide you're going to only use part of it. And so what's left is okay. That makes sense? That would have an inverse function because it's just part of that curve. I can't remember if that one is something I do at the high school or if I have it in your assignment as well. But that's how you do the steps. That's really the important part. This is how you do the steps to find the inverse. Okay? Yeah, so there it is. Let's do another one. Or before I erase that, is everybody okay with that first one? Any questions? Okay. Sorry that I erased the answer at the top. We'll see how good of a zoom in camera she has. All right. Okay, so you guys tell me, what should we do for step one? Okay, hang on, before we go on. It says find the inverse of this. Notice this again is what shape? The U shape. And notice what they've done. They've said we're only going to look at part of it because we want it to pass that horizontal line test. So they've limited, they say we're only look at the positive numbers for x. Okay, so they're looking at half of the graph, which would look like this. So now it's going to have an inverse function. Does that make sense, what they've done? Okay, so now what's our first step that we need to do here? Y equals x squared plus 1. Then what? X equals
y squared
plus 1. Yep. Then what?
minus 1.
Yeah, so now our goal is get the y by itself. You're right. Subtract 1. X minus 1 equals y squared. Square root of both sides. So y equals, now we still have this plus or minus, but I'm going to show you what we do with it. So algebraically, this is what we would get, right? Plus or minus, square root of x minus 1 equals y. But here's where we can get rid of that plus or minus. Right back here, they said we were only using x values that were positive, right? Correct? So when we go down here, which one of these is going to make sure that we have positive values? The plus one, right? So we don't need to worry about the negative. In fact, we can just erase them and it automatically means positive, right? What? No, it's not a trick. It's the positive one makes it positive. So I'm not trying to trick you most of the time. In fact, I usually don't try to. I know sometimes the questions can seem tricky, but I'm not trying to trick you. Okay, so then we write our answer and we would just put in f to the negative first power. It's not really negative. F inverse of x equals square root of x minus 1. Just like that. So that one was shorter. Not as much stuff to do as the last one. Actually, probably one step shorter. Yeah. So when you get to here, then you just replace it with the f of x because then you're done. Or the f inverse of x, I should say. Some of them there's space, it looks like. You're going to block that air, aren't you? You better move up to the front then, I guess. So, okay. Are we good with this one? Okay. Find the inverse of this one. Now this one's a little bit different. I want to talk about the graph first. This part right here is one of our toolkit functions. Does anybody remember what it looks like? I don't necessarily expect you to have them memorized, but hopefully we kind of have seen them a few times. You're close. You're close. He just started swiggling his hands around probably. But if we just look at that, it looks basically like that. It's kind of like an S curve. The 5 just stretches it, so it doesn't really change the shape a whole lot. And the plus 1 does what? Moves it up 1. So does that really change the shape? No. So is it going to pass the horizontal line test? Yeah, it does. Without even making any limitation on it, it's going to pass. So let's take a look at this one. What is our first step going to be? Y equals. Okay. What's our next step going to be? Yep. And vice versa, right? So x equals 5y cubed plus 1. And now our goal, do the math and get the y by itself. So here we have to be a little bit careful here. What do we get rid of first? The 1. Get rid of the outside stuff first. How do we get rid of the 1? Yep, minus 1. So x minus 1 equals 5y cubed. Now this is the part we have to be a little bit careful about because this is the part where people will get mixed up sometimes. The one we have to get rid of next is the 5 because the 5 is not grouped in with that cubed. The 5 is not cubed. Only the y is cubed. Does that make sense? If there was parentheses around it, then the 5 would be grouped in with the y and we'd get rid of the cubed first. Okay? So we have to get rid of the 5 next. How do we get rid of the 5? The divide by 5. So x minus 1 over 5 equals y cubed. What do you think we need to do to get rid of that 3? You're close. It's just a different word, right? In the past, we did the square root of both sides. Since this is a y cubed instead of a y squared, we do what's called the cube root of both sides. So here's what's different about it. It looks the same, except we have an index of 3. And that makes this cancel with this. They need to be the same. Okay? So then our answer, because now we have y equals that. So we would have f inverse of x equals the cube root of x minus 1 over 5. Now, the one thing I will mention when you're typing it into the computer, because the computer, again, is looking for certain things, and if you're not careful, you can type it in wrong. So just make sure that your entire fraction is inside of that radical. Because it would be different if it's a different answer if you write it like this. Does that make sense? So make sure that whole fraction, if you're trying to put the whole fraction inside, make sure that your whole fraction is inside the radical. Because if you put it like this, it's going to count you wrong. Now, when I go look at it again, I'll probably give you most of the points back, but technically this is not this, so you won't get all the points. But you want to be careful how you type that in.
So in that like scenario, there's no, I mean, we don't put the plus or minus, right?
No. And here, okay, so yeah, that's a great question. So the plus or minus, you only need to do if the index number is even. So when we do square roots of both sides, that's the most often one we do. That's why the plus or minus has to be there. With a 3 or a 5 or a 7, you don't need the plus or minus. If it's a 2 or a 4 or a 6, then you would need the plus or minus. That's a good question. Any other questions? Any other great questions that you want to ask? Is it not a great question? You don't want to ask a great question? Okay. So we do get our answer there, cube root of that. And again, just make sure your entire fraction is inside of your radical sign. Now, very quickly, and I know this is not in your notes, I just want to double check. And it's not going to take long, so we're almost done. But I just want to go through our toolkit functions again to kind of review what they look like, but also to ask this question. Which of the toolkit functions have an inverse function? I should probably put function without restricting their domain. In other words, which of them will pass the horizontal line test? Okay, so let's take a look. I've got pictures of them here so we can look. Okay, constant function. Will that pass the horizontal line test? Is there a horizontal line that can intersect that more than once? No. There is. If you draw this horizontal line right here, it intersects all the time, right? So that one is a no. That one would not pass. How about this one? That one's okay. Any horizontal line you draw there will only touch it once. Does that make sense? Once. Okay, it only touch it once. Okay. How about absolute value? No. If you draw a horizontal line up there towards the top, that would intersect twice, right? Okay. How about parabolas? We've already talked about these. That's a no, right? It would intersect more than once. So that one, and again, what we're looking at is these will not have inverse functions that go with them. The inverse will not be a function. It'll have a plus or minus idea in it. So far, only the linear function. Well, let's look at the next one. That one's okay, right? This is the one we just did a couple slides ago, right? 5 times x cubed. So the x cubed is okay. You guys can picture those lines yourself, I think. Okay, how about this one? That one's a little tricky, but it does. If you draw a horizontal line down here, it will only touch here and here and here. If you draw it up here, it only touch once. Okay, and the reason is because it never gets completely flat over here on the left or completely flat over here on the right. It's always going up or down just a little bit. So any horizontal line you draw is still going to only touch it once. So that one would be okay. How about this one? No, horizontal line would hit that twice, right? On the top. And it's any horizontal line. It doesn't have to be every horizontal line, but any horizontal line. How about this one? That one's okay. That would have an inverse. How about that one? Yeah, that's okay. That would have an inverse. And that's it. So another name for these, by the way, if they have an inverse, they're called one-to-one functions. All of these like one-to-one, one-to-one, not one-to-one, 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 not one-to-one. And so you might see that terminology in your homework. I don't remember if they do for sure, but like from these? No, it's just a matter of, can you look at a picture and identify, should it have an inverse or not? It's not something you have to memorize. It's just, you should be able to say, if I give you a picture, some random picture, you should be able to look at it and say, yeah, this would have this is one-to-one, it will have an inverse function. Or no, it's not one-to-one. Okay. 5 of these, I don't think these will take you very long, but like I say, it's the other ones that'll probably take a little bit longer. But get to them. If you have questions, please feel free to email me. And I try and answer fairly quickly. For those of you who have emailed, every once in a while, one will sneak past me. Every once in a while, too, they put it in like email jail. For some reason, as it comes from my open math to Drury and then gets forwarded to me, Drury email puts them in jail, and then I don't get them right away. So if I don't respond, send me another message, and hopefully I'll get it. So